The cyclics continue with greater complexity. What do we have here? The ring's basically always going to be our primary, so here we have a cyclohexane. And what's on it? We have two carbons here, that's an ethyl group, those start with E. We have a methyl group here, one carbon, that starts with M. So we're going to talk about the ethyl group first. This is the first number we've written. We want it to be the lowest we can, so we're going to put that on carbon number 1 and say 1-ethyl. We could then go counterclockwise, 2, 3, 4, and this would be 5-methyl, or obviously if we go clockwise, we get a lower number. We can call this 3-methyl. One-ethyl, 3-methyl cyclohexane. Nothing too bad. Here we have 4 carbons in a ring. 4 carbons is butane, so this is cyclobutane. And for its branch, the branch is a methyl group. We don't give it a number because, of course, it's 1. What else would it be? 1-methyl cyclobutane would be a little bit incorrect or a little bit redundant. We can just say methyl cyclobutane. Let's see here. 5 carbons in a ring is a pentane, so this is cyclopentane. We have a methyl group, those start with M. We have an ethyl group, those start with E. The E goes first, and of course that'll be carbon number 1, so 1-ethyl. And then on the third carbon we have a methyl group, so 3-methyl. 1-ethyl, 3-methyl cyclopentane. What's this? Hexagon. 1, 2, 3, 4, 5, 6. So we have cyclohexane. On that we have a methyl group, another methyl group, and an ethyl group. E goes first, and that's carbon number 1, so 1-ethyl. If we go clockwise, then this is 2, 3, 4, 5. If we go counterclockwise, it's still 3 and 5. So no matter which direction, we're going to get 3, 5, and don't forget your di, 3,5 dimethyl, 1-ethyl, 3,5 dimethyl cyclohexane. This is a cyclohexane. This is actually dimethyl again, so the numbering is the only part that really takes some thought. One of these is going to be carbon number 1, and of course we're going to go the short way to get to the second one. 1, 2 dimethyl cyclohexane. I rushed that a bit. Hopefully that one's okay. This is a funny thing they do sometimes when a molecule has a 3-dimensional shape. They will actually try to show it. So this is 1, 2, 3, 4, 5, and that's a corner there. 6 carbons in a ring. The ring happens to be bent, so it ends up kind of tent-shaped, but nevertheless, it's still 6 in a ring. It's still cyclohexane. The branches on it are an ethyl group, which is going to make that carbon number 1, so we're going to get 1-ethyl. And then if we go 2, 3, 4, this could be 4-methyl, or if we go the other direction, 2, 3, it's 4 either way. That methyl group has to be on carbon number 4. 1-ethyl 4-methyl cyclohexane. When the shapes get more complex, they start doing more and more of this stuff to try to give you a better idea what the molecule is really shaped like, which is nice, but when you're trying to do the naming, it's just a bit of a nuisance. Just put in these dots if you want to help yourself count. That's what I do. Okay, here we have a cyclohex, because it's 6 carbons in a ring shape. There's a double bond which makes this cyclohexene, and you remember from before, you don't have to say cyclohex 1 in because you're automatically going to put carbon number 1 on this thing. Now, a choice we do still have is we could number it this way, and that would put our methyl groups on carbons 3, 4, 5, and 6. That doesn't sound too good. Or, if we number in the other direction and make this carbon number 1 and this carbon number 2, then our methyl groups will land on 3 and 4, which is better, of course. So, this we would call 3, 4, di. Don't forget your di. 3,4-dimethyl cyclohexene. My writing's looking a little rotten on these, so I'm going to see if different zoom helps smooth it out. Okay, another one where they're putting kind of a three-dimensional effect on it to make it look nicer. I don't think this adds much, but it's certainly going to make it a little more annoying to count carbons. If that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's an octagon. That would normally be octane, but here it's cyclooctane. Remember the rule about don't elide vowels, even though this looks a little weird and kind of looks like cycloctane. It's cyclooctane, and chopping out one of these O's might be tempting, but we're not supposed to do that. For branches, we have an ethyl group here. That starts with E. We have 2 methyl groups, which start with M. Ethyl goes first, so this is automatically carbon number 1, and we're going to have 1-ethyl as part of our name. Now, if we go clockwise, we get 2, 3, 4, 5, 6, 7, 8. We would get 2,8-dimethyl. If we go the other direction, this is symmetric, so you know what's going to happen here. 2, 3, 4, 5, 6, 7, 8. We still get 2,8-dimethyl, so it doesn't matter which direction you do your numbering. This name is inevitable. And for O, what have they done with this ring shape? 1, 2, 3, 4, 5. This, again, is a cyclohexane. They've just shaped it funny here. So, cyclohexane, no double bonds to worry about. And we only have a single branch. It's 2 carbons, so it's an ethyl group, so you can just call this ethyl cyclohexane. This branch would automatically be on carbon number 1, so no need to say so.